Hey guys, welcome back again. I hope you are doing well. So, in this video, we are going to solve today's lead code problem and the GFG problem. Okay, so let's see uh, what are the problems. Okay, always let's start with the lead code. Mm, Let's open this. Check if the array is sorted and rotated. So, there's maybe duplicates in the original array, including non-zero. Return true if array originally sorted in non-decreasing order, meaning increasing order, and then rotated some number of positions, including zero. Otherwise, return false. Okay, it may contain duplicates. Great. So the one thing that we know about the rotated, you know, array, that whatever the point of, whatever the point um, where it's rotated. Okay, for example, you can see it's rotated by 3, so you can see we can get this thing 5, which is greater than 1. So before 1 it's sorted, after 1 it's sorted, right? That is what we have to find at the point where it's rotated. Okay, so how we can solve this problem? The one thing that I am getting is uh, you know traverse the array. Uh, it should be there is a flag which will track how many times it's rotated. Okay, meaning that whenever we find the conflict, then the flag will be triggered. The count will be triggered. For example, you can see for the 5 1, there is a peak, and then 5 is greater than 1, meaning it's not sorted here. So we put the count 1, that we found one position where it's sort of not sorted. Then we go again, and yes, the last position, okay, should be lesser than equal to the start position if it's uh, triggered. Okay, meaning that we found at least one conflict in the array. And yeah, that is what I'm thinking. Let's try code in CNT. It will track how many conflict we found. Conflict meaning that the previous element is greater than the current one. Okay, find I, let's say 1, I is less than num sub length plus I, and instead of num sub length I would take an integer, right? And this will be here if nums of I is lesser than nums of I minus 1. If we found this stuff, meaning that uh, you know it is rotated. So the conflict occurred, then plus plus, and at the last, if CND is greater than 1, meaning we found two conflicts, so return false. Otherwise, if there is no conflict, meaning it's equal to 0, then return true. And we can return true. Uh, and here we can check also if CN is greater than 0, meaning we found conflict, and then the nums of 0 should be uh, greater than, you know, greater than equal to the nums of n minus 1. If it's smaller, then return false. Okay. Otherwise, true. Let's try the submit. It's passing. Let's try submit. So it's accepted. And we beat almost 100%. So let's thought about the optimization later on. We need to solve the GFG also. Transform sum to tree. Let's see what is this. Transform to sum tree, meaning given a root of a binary tree with n nodes where each node may maintain positive or negative values, convert it into a such tree into a tree such that each node's new value is equal to the sum of all its left and the right subtree. For leaf nodes, update their value 0. And you can see this sum belongs here, and then these are 0. The sum belongs here, 7 and 5, which is 12. And then the -2, -4 plus -2, which is -6, and 12 plus 6. Let's see what's happened. I will check. It is simple, but need to understand first what's happening. So we put here. Okay. So let's try another, like red colors. First we need to get the value from the leaf node and update it to the 0. Okay. Okay. I can say this is our leaf node value, and then we update it to 0. Similar for this. For going up, we pass the 8. Okay. And here this pass is -4, which eventually becomes -4 -2 plus 8, -6 plus 8, which is what is this? Okay, so we don't have to include the current sum. Let's say our current value is this, but we have to assign the node that value coming from the left subtree and the right subtree, right? So coming from left is 8, and from right -4, then just sum it up, right? So it is 4. Then our current node value will be 4, but we are passing the sum of these. Okay, so we are passing 4 -2 to the up. Similar, we put 0 here and passed 5, 7, which eventually becomes 12. and then we passed 12 plus 6. Okay, meaning that 12 plus 6 is 18, right? And plus this value 4 minus 2, which is 20. Now this became 20, but the root value where it goes, since there is nothing up, so this value remains as it is. Okay, this value we ignored. Yes, so let's try to code for it, and there will be like plain. So you can say some the utility, then we have root. Okay, if the root is equal to null, then return 0, and we pass, you know, we call for the left, root dot left, we call for the right, then it will give some value in left value in right value. So first we need to extract our current right current value, which is current value will be root dot data, and now root dot data will be left plus right. Okay, and return left plus right plus current value. That is what we are doing, right? And we can pass this root here. When we when we are on the leaf node, then we uh, call for the left and right, then it gives 0, which will be stored for that node, and that current, that node's previous value, we will add it to the sum and the pass to the upper, the parent. So let's see it works or not. We forgot the semicolon. So it's working. Let's try to submit. So it's passed. So yeah, thank you for the watching. Okay. You can do the optimization. Okay. Right now I have some work. So yeah, thanks again for watching.